So now we are going to discuss about third chapter, electrochemistry. So what is the meaning of electro? Electro means electrical charge, otherwise electrical energy. Chemistry, here what? Chemical energy. So this chapter is explaining what? The electrical energy is converted into chemical energy is called as electrochemistry 1. It is also called as electrolysis. Next, another important, the chemical energy is converted into electrical energy. It is called as electrochemistry 2. It is what? Electrochemical cell. So now we will discuss first one, electrochemistry 1, otherwise electrolysis. So before going to this, we will discuss about first electrolyte. So which one you called as electrolyte? The chemical substance which is dissociated into ions and transport the current. Then only you called as electrolyte. So which one you can take? Strong acids. So you take HCl, H2SO4, HNO3, like that. Next, strong bases. So you take NaOH, barium hydroxide, so like anything. Next, otherwise salts. You take NaCl, so K2SO4, so Na2CO3, like that. So many concepts. So this electrolyte. Next, when electrolyte is showing conductivity, so it is showing conductivity means in the molten state. Molten state means what? Pure compound. Pure compound in liquid state. So that is called as molten state. Second one, solution state. So solution state means you take the compound, X compound dissolved in water, otherwise solvent. So in these two conditions only the ions can move easily. So means they are transporting the current. So now we will discuss about electrolysis, otherwise electrolytic cell. Electrolytic cell, it is nothing but electrolysis. So here we are taking a electrolytic solution, maybe it is molten state, otherwise solution state. See, one beaker we are taking, in this we are taking NaCl, molten NaCl. Molten NaCl we are taking. Next, it is immersed with two electrodes. One is connected with positive charge, another one is connected with negative charge. So here that Na plus ion is there, Cl minus ion is there. See, the positive charge attracts the negative. So that's why this Cl minus anion is coming towards this side and it coming out as a chlorine gas. So this positive charge attracts negative ion, so anion. So that's why this is called as anode. Next, negative charge electrode attracts Na plus ion and it is deposited. So that means here cation is attracted by negative charge, so that's why you called as cathode. So the important point in entrance, anode has a positive charge, cathode has a negative charge in electrolytic cell, otherwise electrolysis. So here non-metal. So non-metal is coming outside in the form of what? liberated as a gas. One important point. Next, metal. Metal is deposited. See, non-metals are liberated as gases, metals are deposited on the cathode. Next, what happens at anode? At anode, so Cl minus is coming and become as Cl and giving electron. So here loss of electron takes place, so that's why it is called as oxidation. So for balancing purpose, you take 2 moles Cl2 gas is coming outside, 2 electrons. Next, at cathode. At cathode, what happens? Na plus is absorbing electron and become as sodium metal. So here for balancing 2 electrons are coming, so that's why you take 2 moles. So here what happens? Gain of electron. So gain of electron you called as reduction. So now we see at anode what happens? Oxidation takes place and the loss of electron takes place. At cathode we seen what gain of electron takes place, the reduction takes place. So now we will discuss about different, suppose the solution contains different cations are there, different anions are there. So then how to tell which is deposited, which is liberated, based on 2 concepts. One is electrochemical series. So entire the electrochemistry is depending on this series only. So already we know, I think we discussed in previous also our shortcuts. So Lika Namalji. So Lika Namalji Fekadko Nitilehai Kuai Fasil. So Mego, mercury, gold. After iodine, you will get bromine, chlorine, fluorine. So in this, you take any 2. Left one loses electrons. So loss of electron you called as oxidation. In these 2, you take left one, that is acting as anode. Next, right side one gains electrons. So losing of electrons is acting as a anode. Gaining of electron is acting as a cathode. Suppose you take so zinc and copper. So zinc is the left side acting as an anode. Copper is right side acting as a cathode. So this is one important electrochemical series. Another one, anion liberating capacity. Anion liberating capacity. See, this is explaining about cations, this is explaining about anions. So Cl minus is greater than OH minus is greater than NO3 minus is greater than SO4 minus 2, and so that is. So negative charge increases means it will go. See, suppose in the solution Cl minus is there only. It is coming out as Cl2 gas. OH minus ion is there, coming out as O2 gas. NO3 is there. So NO2 gas is coming outside. Sulfate is there. SO2 gas is coming outside. Suppose the solution contains chlorine, chloride ion, hydroxide ion. Chlorine only coming outside. Chloride is there, nitrate is there. Chloride only coming out as a chlorine. Suppose OH minus is there, NO3 minus is there. So OH is coming outside as O2. These two only play important role in the entire electrochemistry. So now we will discuss about the electrolysis of some compounds. So first you take electrolysis. Electrolysis of aqueous NaCl. So aqueous NaCl. Aqueous NaCl means what are that? Aqueous is there means H plus is there, OH minus is there, Na plus is there, Cl minus is there. So this contains two cations, two anions. Now only we discussed in two cations who is coming outside. See, H plus is there, Na plus. In our Likhan-Amalji shortcut, sodium is left side, hydrogen is right side. Sodium loses, so means it become as Na plus. Hydrogen is taking, so that means hydrogen gas. So you must concentrate our previous electrochemical series. Now Cl minus is there, OH minus is there. Already we seen anion liberating capacity. ClOH is there means Cl only coming outside as Cl2 gas. OH is present as OH only. See, this is before electrolysis. This is after electrolysis. So what happens here at anode? At anode means chlorine gas is coming outside. At anode, chlorine gas is coming outside. At cathode, hydrogen gas is coming outside. Direct, everyone is question only. At cathode, which gas is liberated? At anode, which gas is liberated? When electrolysis of aqueous NaCl. See, after the electrolysis, what happens? Hydrogen gas is going outside, chlorine gas is going outside. Remaining solution contains what? NaOH. So NaOH means the solution is become as a basic solution. This is also question. Next, what happens to that pH? Also they can ask the question. NaOH means the pH is what? Greater than 7 also. Next, another example we will see electrolysis of aqueous copper sulfate. So aqueous copper sulfate solution. See, before the electrolysis, who are present? Aqueous means H plus is there, OH minus is there. Next, copper plus 2 is there, SO4 minus 2 is there. See, here two cations are there and you see where the location in our Likhan-Amalji Fekadko shortcut. So hydrogen is left side, copper is right side. In that series, you must observe the series. So hydrogen loses electron. It is losing means H plus only. Copper is taking electrons. It is Cu. Next, OH is there, SO4 minus 2. Anion liberating capacity. You go and see the anion liberating capacity. OH and SO4. OH only coming outside as O2 gas. Next, H2SO4. That is SO4 is as it is SO4 minus 2. So that means at anode oxygen is coming outside. At cathode copper is deposited. So this is before electrolysis, this is after electrolysis. Which is liberated, which is deposited, that also questions. Next, after that electrolysis, what happens? Remaining solution contains H plus is there, SO4. So that become as H2SO4. So which type of solution this is? Acidic solution. So after electrolysis of copper sulfate aqueous, what happens? The solution, it become as acidic. Acidic means what happens in pH value? The pH is less than 7. So they will ask the question, who is coming outside at anode, who is coming outside cathode, what happens to the solution, what happens to the pH also, they will ask the direct question. In the electrolysis only, we have two important famous laws are there. So that are Faraday's laws. So Faraday's laws two are there. So before going to Faraday's laws, we must think about our current. So which one you called as current? The flow of electrons. See, one electron charge equal to 1.602 into 10 to the power of minus 19 coulombs. See, 1 mole electrons means what? Avogadro number 6.022 into 10 to the power of 23 electrons. So now I am asking 1 mole electron charge. So means 6.022 into 10 to the power of 23 into 1.602 into 10 to the power of minus 19. So total you will get 96,500 coulombs. It is called as 1 Faraday. So we are sending 1 mole electrons means we are sending 6.022 into 10 to the power of 23 electrons. Otherwise, suppose we are sending 1 Faraday current means you must feel we are sending 1 mole electrons. Otherwise, 96,500 coulombs of charge we are sending. See, here you see the examples. So you take only Na plus. Sodium cation, charge is plus 1. It wants only 1 electron. Then only it become as sodium. Suppose I will take 1 mole. 1 mole Na plus wants 1 mole electrons. How much sodium is coming? 1 mole of sodium is coming. 1 mole electron means what? We are sending 1 Faraday current. 1 Faraday current means 96,500 coulombs we are sending. So how much deposited? 1 mole of sodium means how much weight? That is 23 grams. See, we are sending 96,500 coulombs, then sodium is deposited 23 grams. Suppose I am sending 1 coulomb current only. So how much it is deposited? Cross multiplication. So your answer is 23 by 96,500 grams will be deposited. So you concentrate here. Whenever we are sending 1 coulomb current, weight by 96,500 grams is deposited. Now, second example you take. Magnesium plus 2. Magnesium plus 2 wants 2 electrons. So, it becomes as magnesium. Suppose now you take 1 mole of magnesium ion wants 2 moles of electrons. Then you are getting 1 mole of magnesium. So 2 moles means what? 2 Faraday current. 2 Faraday means what? 2 into 96,500 coulombs current we are sending means 1 mole of magnesium is deposited. Atomic number is 12, double. So that is what? 24 grams. Suppose you concentrate. If we are sending 1 coulomb current only, so how much is deposited? So you take a cross multiplication. So that is what? 24 by 2 into 96,500 grams will be deposited. What is 24 by 2? 24 means it's a atomic weight. By 2 means what is that? Valency. So weight by valency. That means what? Equivalent weight. Suppose we are sending 1 coulomb current means how much it is deposited? Equivalent molecular weight divided by 96,500 grams will be deposited. So this point only important for us. We will see another example. Suppose you take aluminum. Aluminum charge is plus 3. So it wants 3 electrons. So then only it becomes as aluminum. So here 1 mole of Al plus 3, we are taken 3 moles of electrons. Then 1 mole of aluminum is deposited. So 3 moles of electron means what? 3 Faraday current. 3 Faraday current means 3 into 96,500 coulombs we are sending means how much it is deposited? 1 mole. 1 mole means, see, atomic number is 13. So double 26, odd number. So 1 you add. So 27 grams. Suppose 1 coulomb current only I want to send. How much it is deposited? Cross multiplication you take. 27 by 3 into 96500 grams. So here also 27 by 3. So atomic weight by valency. This is what equivalent weight. So always you remember, if we want to send 1 coulomb current, how much it is deposited? Equivalent weight by 96500 grams will be deposited. So if you perfect this one, our Faraday's first law is going to become as easy. Suppose we are sending 1 coulomb current, how much it is deposited? Equivalent weight by 96500 grams. So now Faraday's first law. So Faraday's first law. See, we are taking already we've seen, we take electrolytic solution. Next one is connected with positive, another electrode is connected with negative. If we are sending a current means some are liberated as gases, some are deposited. See, non-metal is liberated as a gas, metal is deposited on the, see here, anion. So that's why it is anode, cathode. See, suppose you are sending a less amount of current. So less only liberated, less only deposited. Suppose you are sending more current, more non-metal is liberated as gas or more metal is deposited. So that means what? The liberating capacity amount or deposited amount is directly proportional to the sending current. So that's why you can take mathematically in what way? The deposited or liberated mass is directly proportional to sending current. So current in coulombs. So that is Q. So here M is directly proportional to coulomb. Coulomb you can take what? I into T. So Q equal to I into T. See, I is in amperes. So T is in seconds. Ampere current, T is time in seconds. So the ampere second you called as a coulomb. So here proportionality constant you remove. M equal to Z into IT. So how to find out the Z value? Suppose we are sending 1 ampere current in 1 second, nothing but 1 coulomb current. So 1 coulomb current, if Q equal to 1 coulomb, then the amount of mass is deposited, that equal to Z. So already we discussed this one. What is that? If we are sending 1 coulomb current, how much is deposited? Equivalent molecular weight by 96500 grams will be deposited. So this is nothing but Z value. So therefore what is the Faraday's law? M equal to Z. Z means what? Equivalent molecular weight by 96500 into I into T. See, in the problem they will give E value, I value, T value, and what is the M value they can ask. Otherwise, you can expand this equivalent weight. Equivalent weight equal to M equal to, so molecular weight by valency into 96500 into I into T. This is a total equation. See, in sometimes they will ask valency. Valency is nothing but oxidation state. Suppose aluminum is deposited this much amount when we are sending this much of current and this much of time. Then what is the oxidation state they will ask. So don't think the oxidation state of metal they are asking means you must concentrate, that is valency only. You find the valency. So this is first law of Faraday's. So now we will discuss about Faraday's second law. Second law. So it is similar to first law only. So what is the Faraday's first law? M equal to E, equivalent molecular weight into valency into 96500 into I into T. See, suppose I into T is nothing but a Coulomb. Current is constant. How the current is constant? Suppose you take it is a constant. So in according to physics also, how the current will be constant? So means you take different electrolytic cells, they are taken in series manner. See, different electrolytes you are connected in series manner means this current will be constant. So valency is for every metal is constant. This is also constant. So that means M is directly proportion to equivalent molecular weight. So this is nothing but Faraday's second law. So when it is happened, you take different electrolytic solutions, they are connected in series manner. In series manner means current is constant and these two already constant. So that's why M is directly proportion to equivalent molecular weight of the compound.